Hello friends, this is Kundan from technical team of Networkers Home. Today I am going to discuss the topic that is floating a static route. Hello friends, this is Kundan from technical team of Networkers Home. Today I am going to discuss the topic that is floating a static route. So today my topic is floating a static route. In this, what happens in floating a static route? If we have redundant path for particular destination from source, what the entry we are executing, that entry is going to get the first preference. And the what is floating a static route? Here actually in floating a static route, under the redundant path, the path which we want to prefer first, either to enter that entry first, or practically that path is going to preferable get the first preference. We need to statically add the AD value of second part. So the next part which having least AD value automatically got the preference. Here in this diagram we have router 1, router 2, router 3, router 4. 4 routers are there. So router 1 having 2 paths for router 4, router 2 having 2 paths for router 3, router 3 having 2 paths for router 2 as well. Each and every router vice versa consists the 2 paths. The configuration is that on router 1, I have added router 4 loopback 10.4.4.4. I have preferred 13.3. What actually this 13.3? This is the route from router 1 to router 4, that router 3, F01 interface, that path is going to get the preference. And then second path is 12.2. It means automatically router is going to prefer 13.3 first because that is the path. And if we want 13.3 if we want to use the track command, traceroute command, that is going to get the first preference. In this thing, what we need to do, manually we will increase the AD value of 12.2, that is going to get the first preference. In the router 2, I have mentioned for 10.3.3 on router 2, for router 3 loopback, I have first mentioned exit interface entry. That is the IP address of next hop router 12.1. Under static route, if we are going to mention IP address of next hop router, that is getting AD value 1 and on exit interface AD value 0. If router having both AD value 1, in that circumstance, the route which is entered first will get the first preference automatically. Every time. Here it will prefer 12.1. On the router 3, it is going to prefer F00 interface towards router 4. And on router 4, I have added both interface, exit interface name. That is not going to work practically. If we are finding this thing in our diagram, same diagram we have here. So on router 1 right now you can see, so IP route, that is 13.3 and 12.2. So IP route 10.4.4. Now preferable path. Right now it shows 12.2 on router 2. What we are getting, so IP route 10.3.3.3. It shows 12.1 because that I have already shown, that is entering the first thing. On router 3, that is so IP route, we have 10.2.2. It will show you F0/0 at 13.1 directly connected, then F00. And on router 4, we have this thing. Do so IP route. Here you can see I have mentioned both interface name. From router 1, if I will try to ping 10.4.4.4, I am getting the reply. But from router 4, if I want to ping router 1 loopback 10.1.1.1, we are not able to get the reply, because rule of floating static route is that if we have the redundant path and both path I am going to mention exit interface name, that is not going to work. If I want to get the ping reply connectivity, then manually one of the path I need to increase the AD value. Right now I am selecting this F01 and I'm mentioning AD value, suppose that is 50. And after that, if I will try to ping 10.1.1.1, I am getting the reply. So one thing we need to keep, that if redundant path available, so both paths we no need to mention the name of the exit interface. If that is there, manually we need to increase the AD value of one path. That's the thing we have with the floating static route. That's fine. So, but on router 1, that is trace route 10.4.4.4. So first path is source 12.2. Static route router is not going to exchange its own routing table. There is nothing like this. If routed to this F01 interface sets, then we will not able to get the reply. See here, that is interface F00, set this interface. And then try to ping 10.4.4.4. We will not able to get the reply because automatically route is not going to converge. It is not the dynamic routing where they are updating second path automatically based upon their algorithm. To overcome this thing, we are implementing that is IP SLA along with the track command. If I will no set again it here, and from routed 1, if I am going to ping again, I am getting the reply. But it's not possible that every time if router 1 interface will went down automatically, it will take the second path. But that should not a scenario. Actually, we want if router 2 and router 3 path went down, automatically that should notification comes on the router 1 and it should handle that thing. That we required properly. How to update that thing? For that, we need to implement this command that is called SLA thing. Here the thing is that on router 1 first we required IP SLA, service level agreement. Any number I am giving the number 1. Then we have the ICMP echo. What I want to verify, that is 13.3 if that port went down and the source interface connected F01. What I want when router 1 try to access router 4, so router 3 path will get the first preference. That I want to implement here. So that's why first SLA, that is 13.3 timeout frequency threshold, that thing we applied, and then we need to enable that thing. We are creating this, all the parameters, and that need to apply properly here. That is IP SLA schedule 1 live 4 over start time now. Then second SLA also required because we have the 2 path. If that path went down, automatic that path should get the preference. That is the most important thing we need to verify. So second SLA I am mentioning 12.2, this interface address, and then my source interface F00. This is the same. And then we need to this track, and after that, that track object need to implement under static route. So that I need to implement first. For that, I am just copying this command here. I will apply before that I need to remove that static route from router 1 itself. Rule is that remove that static route from your routing table. Now we do not have any path for router 3. After that, first we need to apply all this configuration. Now I need to apply this particular part on router 1. So copy this thing here. and paste here. First SLA I have created, do show IP SLA1. Now this statistics I have just created SLA1. Same thing I need to configure SLA2 here. I will apply same configuration here. And after that, do show IP SLA statistics. If I will verify that thing here. Now we have two SLAs ready. Now I need to create the track object. That for track 15 for SLA1, track 25 for SLA2. I am going to implement that thing here. Exit. Then we have for SLA2, and that I'm making it 25. So track 1 having SLA1, track 2 having SLA2. Now I'm going to configure static route again, IP route 10.4.4.4, it's subnet. Then exit interface, suppose that is 12.2. Here I'm using its priority value, I'm giving it is suppose 175, and track that is 25 I'm implementing here. Second, I'm mentioning track 15. That value is 150, and that interface towards the router 3. So I have now configured static route again and apply this thing here. If you will see here, so IP route 10.4.4.4. So now it is 13.3. Trace route 10.4.4.4. It is following 13.3, 34.4. We have applied that thing. And now, so IP SLA statistics, that is working there. And then we have the show track. All right. Now fine. So what we required, when we try to verify this particular route, when the router 3, this interface, suppose this interface went down automatically, router 1 will get the notice that part went down, I need to change my path. So let's verify this thing again here. On router 3, interface F01, set this interface. We will receive here that this interface went down automatically. Now what we have message? Track IP SLA1 reachability up down. If you will see here, so track again. Now that is down, this is up. And then so IP, that is route 10.4.4. Automatically that path has changed. Previously it was not there. When I have set the interface of F00, we was not able to get the reply from router 1 to 4. That was not executing properly. Right now I have set this interface part, and now automatically that this has changed the path. So trace route 10.4.4. Now you can see here this path become active. So we no need to apply anything on router 1. So that's why we required SLA, where we have the static part of configuration, where router is not going to exchange its routing table. In that case, we require SLA. But SLA is not going to work alone. We can enable SLA, apply SLA, configure SLA. Without track is not going to work. So now again, if on router 3, just up this interface, you will get message automatically and that path will come to the default what we have decided. So router 3 get the first preference. That we will get automatically there. So now you can see we have the message of down and up. So again, so IP SLA statistics. Now it is working, and then so track. So that is up. So IP route 10.4.4.4. Again, it is 13.3. Trace route 10.4.4.4 and source 10.1.1.1. It is 13.3. So when we have redundant path under static route, so that is required. Configure the track object. Recall SLA under track object. That track object first is 15 for IP SLA 1 reachability, IP SLA track object 2 this is reachability. That we need to configure. After that, here we have created SLA 1. Before that, remember, once you want to do this practical, that static route should remove practically. After that, again, create the static route along with the track object that is going to work. Now here we have the IP SLA 1, that is ICMP echo. I want to verify if router 3, this 13.3 means F01 went down, automatically I should get the notice what the source interface where I am getting the echo reply, echo thing. It will get automatically that source interface where I will get the notification source interface F01. Then you need to decide the threshold, frequency, timeout, that the thing. And then you need to apply this SLA, schedule 1. That is IP schedule 1, that is SLA 1, live forever start time now. And then because we have the redundant path, so second path we have applied toward the router to have mentioned here, and then you need to apply. So automatically you will get this thing. That the purpose of here we have what is floating static route. That is, if we have the redundant path, like router 1 having redundant path, every router in this having redundant path from source to destination. So entry which is going to enter first will become the first preference. If we want to prefer particular entry should get the access first. Then manually increasing AD value is called floating static route. That route is going to get the preference. Another thing we need to remember, if we have the redundant path, both exit interface is there. In that case, 13.3, 12.2 for router 1, for the router 4 loopback. Both entry having AD value 1, it will work properly. The entry which is going to enter first, it will get the first preference. Second thing, mentioning IP address of the next hop router, and then it is AD value 1, AD value 0, it is going to work. AD value 0, AD value 1, it is going to work. But both AD value will become 0, then we will not able to get the reply. That we need to take care. Here also, if both AD value 0, then what we required, we need to increase the AD value 1 path manually, then second path is going to get the preference. That's the first thing we have. What the another thing we have? That if, like for example, I have mentioned on router 1, router 3 is my preferable part, then second path is the router 2. If router 3 F01 interface went down, it starts, then automatically router 1 should activate its second path, that we required SLA. Then parameters of the SLA, ICMP code we want to judge for the ping command, and then we need to apply using IP SLA schedule 1 command, and then use the track object, remove static route first, apply that as static route again, it will work. That command I have already applied this command here. So thank you. Next time we will discuss dynamic routing protocol stuff.